Morning, sir. My name is TIOTSE DOUNGMENE BERTRAND Jr. And the purpose of this video today is to explain the SmartSchool Cloud NS3 simulation. SmartSchool is the name of my project. So what is SmartSchool? SmartSchool Cloud is a cloud-based system hosted on a centralized cloud server, and it is accessed by students, teachers, and administrators over a wide area network where they can monitor attendance, see their results in real time, share lectures, and all the rest. So the main objective of this simulation is to evaluate the feasibility, the performance, and reliability of SmartSchool Cloud using the NS3 network simulator in a realistic one environment, together with the help of NetAnim. So what I'm going to do now is to start by running my C++ file. So here currently the NS3 simulator is building the code in order to generate an animation file, an XML animation file, and a CVS file for the matrix. So as we can see here, we have our SmartSchool animation file that has been generated here. And also we have our SmartSchool matrix CVS, which is like the data that will enable us to observe and determine the performance reliability of the system. So what I'm going to do now is to launch NetAnim in order to open our animation file. So here is NetAnim, which is our animator, where we are going to open our animation file in order to view the network. So here's our network topology. So it consists of 5 students, 3 teachers, 2 admins, 1 router, and a cloud server. So I'm going to launch the network, launch the animation. And so all the nodes here are connected using a point-to-point one links with a bandwidth of 10 megabits per second and a delay of 20 milliseconds, where each group of nodes is placed on a different IP subnet to enable proper routing. So our network consists of 2 applications. Our simulation consists of 2 applications, which are the TCP applications and the UDP applications. So basically the TCP applications is meant to simulate large net and reliable data transfers, such as attendance, submission, result uploads, and record access. While our UDP applications is meant to provide low latency communication for real-time updates. So here, all nodes use a constant position mobility model. What does that mean? This means they remain stationary throughout the simulation. NetAnim is used for visualization where nodes are labeled and color-coded to distinguish students, teachers, administrators, the router, and the cloud server. So in my code, I assigned a blue color for the cloud, a gray color for the router, green color for the students, and an orange color for the teacher, and a red color for the admins. So as we can see, the packet flow animations clearly show TCP and UDP communication in real time. Here we can see the statistics with the IP address of each node and their MAC address. So I'm going to stop the simulation here and move to our metrics in order to evaluate the data. Yes, so this is the CVS, the CSV file generated for the metrics. And as we saw in the simulation and what we are seeing from the metrics, we observe that the TCP traffic reaches the cloud server reliably, that the UDP notifications were delivered with minimal delay. Packet loss is very low as we can observe. Also, the cloud server handles multiple users simultaneously, and this demonstrates a good network performance and scalability. Thanks, sir, for watching. So before I end the video, and from what we just saw from the simulation and the metrics, I can conclude that the Smart School Cloud is a reliable and scalable cloud-based solution for educational institutions supporting centralized data management and real-time communication over one. So thank you, sir, for watching.